Welcome viewers. In this video we will see the construction and operation of single phase induction motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, construction and operation of single phase induction motor. Normally the single phase induction motor is a small size motor used in domestical purpose with a fractional kilowatt rating. Three-phase induction motors are used for industrial purpose with more power rating. The single-phase motors are less power rating, small size, mostly used for the domestic purpose. So it is based on the electromagnetic induction. The working principle of this single-phase induction motor is the principle of electromagnetic induction to create the rotating magnetic field. Now we'll see the diagram of a single phase induction motor. Normally in single phase induction motor, if we have only one phase, then the net flux will be zero. For example, so this is the alternating voltage we are applying. So the alternating AC voltage is applied, so the flux also produced in alternating nature. If only one winding available means this is the positive flux, this will be negative flux, positive off cycle, negative off cycle. So the flux produced in the positive off cycle is positive, during negative off cycle is negative, so both got cancelled. The net flux will be zero. The flux, this is the flux will be zero if we use the only one winding. Because of alternating nature, positive and negative alternatively changes, so the net flux is zero. So normally in single phase motor we are using two windings. See this, running winding and starting winding. This running winding is connected directly, starting winding is connected through the capacitor. What is the nature of the capacitor? It will lead the current. So the current is lead in the starting winding and current in the running winding is normal. So what will happen? We'll see the diagram. So this is the flux produced in the running winding. But in case of starting winding, the current will leads. So there is a phase difference. There is a phase difference between starting winding and running winding because of capacitor. Now the flux is not zero. Always some amount of flux will be available. So that flux is used for rotating the motor. Right? So in single phase motor, induction motor, if you use only one winding, the net flux is zero. So we are converting into two windings called starting winding and running winding. This starting winding is connected with the capacitor, so the current leads. Running winding is connected normally. So there is a lag, there is a phase difference occurs between the current flowing through the starting winding and running winding. So there is, due to the phase difference, always some amount of flux is available in the motor. So that flux is used for rotating the induction motor. Now we'll see the full diagram. So we know that the induction motor, normally in motor we have rotor and stator. Rotor is a rotor, squirrel cage rotor. Rotor is the rotating part, and stator is nothing but a stationary part contain the windings. Right. First we will see the rotor. This rotor is a squirrel gauge rotor. Like three-phase induction motor, is a squirrel gauge rotor. Squirrel gauge rotor means it contains the slots in a skewed manner, not a parallel manner. It is available in a skewed manner. Skewed manner means so that the losses will be reduced. In these slots, the copper, aluminum or brass the bars are available. Permanently bars are placed, not a coil. It contains the aluminum bar or brass or copper bars are placed. So that will be connected in a closed circuit. It will act as a closed circuit. So the rotor is a squirrel gauge rotor, contain the skewed slots. In that skewed slot, the aluminum bar or copper or bronze bars are permanently placed, not a coil. Permanently bars are placed. All bars are connected together, so it will act as a closed circuit. Right. So this is the nature of the rotor. In case of stator, we have stator winding. Stator slots are available, in that the coils are placed. Here the two coils available, running winding and starting winding. This running winding L1, starting winding L2. So the starting winding is connected through the capacitor and centrifugal switch. So we already discussed, due to these two winding, this L1 is connected directly to the supply, L2 is connected through the capacitor. So there is a lag between starting and running winding. Due to that, some amount of flux always produced. So that flux will develop in the motor. If only one winding means the net flux will be 0. So due to the flux, this rotor, the EMF is induced in the rotor. Whenever there is a rate of change of flux, EMF is induced in the rotor. This rotor having copper or aluminum bar that are closed circuit. So due to the closed circuit, current is flowing through the squirrel cage rotor. Current is flowing through the rotor. Now this will act as a current carrying conductor. Whenever a current carrying conductor placed in the magnetic field, it experiences a force. So due to that, it will start rotates, right? When it is rotates, due to the force, because of centrifugal switch is connected, the switch got open and starting winding is disconnected. So the starting winding used only for starting purpose. That's why it is named as starting winding. After, once the motor start rotating, due to the centrifugal switch action, it is disconnected. Starting winding is disconnected. Now the motor will start rotate in a normal speed, the rated speed. So here we have rotor and stator. Rotor is squirrel cage rotor. Copper bars are available from the closed circuit. Stator, we have starting and running winding. Running winding is connected directly. Starting winding connected through capacitor. So there is a lag available. There is a phase difference available between two windings. So the flux produced also having the phase difference. So the net flux always available. That flux will create the EMF in the rotor. Due to the EMF, current is flowing through the coil, flowing through the bar. So it will act as a current carrying conductor. This current carrying conductor placed in the magnetic field will experience a force. Force means it will start rotate. Once it is start rotating, due to the centrifugal action of switch, the switch is disconnected. Switch is open. So the starting winding is disconnected. So starting winding used only for starting purpose. Thereafter it is disconnected. So this is the operation and construction of the single phase induction motor. Now we'll see the description. These details are available. What we discussed, the details are available. We'll see this one by one. So the construction. So like the other electrical motor, asynchronous motor. So the induction motor normally called as asynchronous motor. Synchronous motor means always rotated in rated speed, but this is not rotated in rated speed. When the load increases, speed will decrease. The two main parts are rotor and stator. What is stator? It is name indicates. Stator is a stationary part of the induction motor. A single phase AC supply is given to the stator of the single phase induction motor. So stator is nothing but a stationary part. In that, AC supply is given. Now we'll see the rotor. The rotor is a rotating part of induction motor. It connects the mechanical load through the shaft. The rotor in the single phase induction motor is a squirrel cage type of rotor. So the rotor, stator is a stationary part, rotor is a rotating part. The mechanical load is connected through the rotor through the shaft. It is a squirrel cage type. Now we'll see the stator of the induction motor in detail. Now we'll see the description. I will see in detail what is the stator, what is the nature of stator. The stator of single phase induction motor has laminated stampings. The stampings are laminated in order to reduce the eddy current loss on its periphery. So it contains the laminated stamping to reduce the eddy current. The slots are provided with stamping to carry the stator or main winding. The stamping means there is a place in which the coils are placed. some space will be there, in that the coils will be placed. I will see the further detail. These stampings are made up of silicon steel to reduce the hysteresis losses. Right? So the laminated stamping already available to reduce eddy current loss. Now it is made up of silicon steel to reduce the hysteresis losses. When we apply a single phase AC voltage to the stator winding, the magnetic field gets produced and the motor rotates at the speed slightly less than the synchronous speed. So when the AC supply is given, what will happen? Magnetic field will be generated, what we discussed earlier. The speed of the motor is nothing but ns 120 f by p, synchronous speed, but it is slightly less than the synchronous speed. Ns equal to 120 f by p. What is that? This f is nothing but supply voltage frequency. P is the number of poles of the rotor. Now we will see the further detail. The construction of stator of the single phase induction motor is similar to the three phase induction motor, except there are two dissimilarities in the winding part of the single phase induction motor. So almost it is very similar to three phase, only two major differences are available. Now we'll see what are the differences. First is, single phase induction motor are mostly provided with concentric coils. Yes, concentric coils are available. We can easily adjust the number of turns per coil with the help of concentric coils. The of distribution also sinusoidal. It's not a distributed coil, it's a concentric coils are available. So we can easily adjust the number of turns. That is the first difference between the single phase and three phase. In all types except for shaded pole motor, an asynchronous motor include two stator winding, the main winding and auxiliary winding. These windings are positioned at right angle to each other in what is known as space quadrature. So we already is a starting coil and running coil. So here it is named as main winding and auxiliary winding. Then only there is a flux will be produced. Only one winding available means the flux is 0. So that we have main and auxiliary winding. So in three phase induction motor, automatically three phases are available. So the flux will be produced automatically. But here we have two windings. We are using two winding, main and auxiliary. That is the one difference. Another difference is concentric coils are available. Now we'll see the rotor or the details about the rotor of a single phase induction motor. The construction of rotor of the single phase induction motor is similar to screw gauge three phase induction motor. Screw gauge means the copper bars are available. The rotor is cylindrical and has slots over its periphery. It's a cylindrical type. Now we'll see the further detail. The slots are not made parallel to each other, but it is little bit skewed. I already told. It is not a parallel, skewed. The skewing prevent magnetic locking of stator and rotor teeth and makes the working of induction motor smooth and less noisy. Normally it is parallel, but here not a parallel, skewed to avoid the magnetic locking between stator and rotor, so that it will rotate smoothly and with less noise. The screw gauge rotor consists of aluminum, brass or copper bar. I already told, not contain any coil, contain the bar. Aluminum, brass or copper bars are available. These aluminum or copper bars are called rotor conductor and placed in the slot on the periphery of the rotor. In the periphery, these bars are placed. The copper or aluminum rings permanently short the rotor conductor called the end rings. So it is closed circuit. I already told it is closed circuit. So permanently it is short circuited to form the closed path. To provide mechanical strength, these rotor conductors are braced to the end rings and hence form a complete closed circuit resembling a gauge. Hence got its name as screw gauge induction motor. So it is completely form a closed circuit. In order to give the mechanical strength and form the closed circuit is available. So that it is called a squirrel cage induction motor. As end rings permanently short the bar, the rotor electrical resistance is very small and it is not possible to add external resistance and bars get permanently shorted. In case of three-phase induction motor, we can externally connect the resistance because of the construction, but here it is permanently connected, so we are not able to connect any external resistor. That is the point given here. So that external resistance used for speed control. Here it is not possible to add any external resistance. Now we'll see the further detail. The absence of slip rings and brushes make the construction of single phase induction motor more very simple and robust. Right? There is no slip ring and brushes are available. If slip ring and brushes are available, mean there is a noise will be there. Then there is a maintenance. We need to replace in a frequent manner. But these are all not available in that. So that it is will be very simple. Construction is simple and robust. Though now this is the construction. Stator and rotor. Now we'll see the working principle. Working principle of induction motor. What we discussed, the description is available. According to Faraday's law of electromagnetic induction, EMF get induced in the rotor. So when the supply is given, flux is produced in starting and running winding because of phase difference. That flux will link with the rotor. Due to that electromagnetic induction action, EMF is generated in the rotor. As the rotor circuit is closed one, so current start flowing through the rotor. This is called a rotor current. I already told the copper or brass or aluminum bars are available. They are connected with the end rings. So it will act as a closed circuit. Due to that current is flowing. That is called a rotor current. Now the rotor current is flowing. The rotor current produces its flux called a rotor flux. The rotor current also flux one more flux. Since this flux is produced due to the induction principle, so the motor working on the principle, it is named as induction motor. So this induction between stator and rotor, EMF is produced. Due to the EMF, the rotor current is flowing. Due to the rotor current, another one more rotor flux is produced. So that is called a induction based on the induction principle. Now there are two fluxes. One is main flux, another is rotor flux. These two fluxes produce desired torque which is required by the motor to rotate. So I already told, when a current carrying conductor placed in a magnetic field, it rotates. So it will be start rotating with a desired torque. So this is the working and construction and working principle of a single phase induction motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.